Hey everybody, Joe here. Welcome to my shop. Before we get started with today's little project, I'd like to take the opportunity to thank all my subscribers. I've been getting some really great comments on my channel, and I really appreciate it. It keeps me motivated to make these videos for you guys. So with that, we'll head over to the lathe and start today's project. Okay, another little shop project here. This is my boring head, and it typically rides on this R8 arbor for doing boring on the milling machine. But what I want to be able to do is mount this in my tailstock so that I can offset to turn tapers between centers without upsetting the actual centering of my tailstock. So what I'm going to do here is I'm going to turn this end, this thread, and this collar on the end of this piece of 2-inch bar stock, and then instead of turning the R8 taper, I'm going to put a Morse taper 2 on it, so I can just plug this right into it, and then I can do long tapers between centers on my machine. So I got a piece of stock here. It's mystery metal, but I'm pretty sure it's some kind of alloy because it's kind of tough, and I'm going to stick it in there, and I'm going to turn a taper on this end, a Morse 2. And then what I'm going to do is I have one of these, which is a Morse taper 5 on the OD to a 2 on the ID. And I'm going to stick this in my lathe headstock naked, and then put the taper that we turn into it, and that'll make it run true, and then we can make this end of it right here, thread it and turn it down and all that kind of good stuff. So let's get going here. Alright, so I'm just facing this off, and then I'm going to put a center in it. It's another 100-degree day in here, so if you're getting some wind noise, it's from the fan. Supposedly tonight, we got a big front going through, and tomorrow it's going to be like 70. Alright, so marked off a spot here, 2.8 from the end. I got to turn this 2-inch bar down to 3/4 of an inch, or thereabouts, which is going to take silly time. So I'm not going to film that. I'll just come back when we're getting close. Alright, we're cutting here. And man, I'll tell you, These chips are hot. This piece is smoking. I was taking 50 thousandths cuts off of this thing, trying to get it down there. I'm not sure what kind of alloy this is. I'm pretty sure it's not the 41, series chrome moly stuff, but it is turning blue, and the chips are great. I mean, just little curlies there. But right now I'm letting this thing cool down a little because it's getting pretty damn hot. So we'll just get back at it when things get reasonably cooled down. I'm using carbide on this, and 450 on the RPM. So yep, I'll bring you back when we get down to 3/4, which will be our starting taper size. That was 50 thou, man, and I'll tell you, you do not want to have any of these chips hit you. I've got little tiny burns all over me, and when they're hitting the floor, it smells like burning wood. That's 100 thou cut right there. Okay, this shaft is now turned down to exactly 750, and what I did was I looked up in the handbook there, and the final big end dimension on this thing's 700, but the reason I turned it to 750 is because I thought about it, and I really don't want to take this out of the chuck because right now this thing has 0 run out. So what I'm going to do is I'm going to use my ER collet chuck with a 3/4 inch collet in it, and this will give me my reference taper. I turned this quite a while ago, and it was a real good match to the tailstock taper. So I'll get that set up, and then we'll start dialing in the compound for the required angle here to get this thing ready to turn. Okay, so let's talk about dialing in a taper here. I've rotated my compound to an angle that is close to this thing just by eyeball, and I know it's off. So what I'm going to do here now is I'm going to move the compound back and forth. I've got a dial indicator on the compound, and you can see that as I rotate this towards the end, the indicator is climbing. So what that tells me is that this angle on the compound is too far this way. So what I'm going to do, I don't have the compound tight. What I'm going to do is I'm just going to start tapping this thing. Okay, now run it back again. Okay, it's still climbing. Getting better. Okay, so you just keep doing this until this dial indicator doesn't move. I'm going to snug it up a little bit here because it's a little loose. Okay, it's getting a lot closer now. So once I get this to the point where it's not moving, then I'm going to switch to my tool post indicator, which is a tense indicator. Light taps now. Okay, I went a little too far. So we'll bang it back just a hair. It's kind of tedious, but alright, couple of thou here. Okay, so that's close enough that I can get it on my tense indicator, so let me switch to that. Okay, so that's a little better for you guys. So one critical thing that you have to make sure is that this indicator point is on the center line of the taper, otherwise it'll be wrong. So what you do is you start, you raise and lower this thing until you get the maximum, which is about right there. And now it looks like it's perfectly on center to me. So what I'm going to do now is I'm going to start dialing the compound back and forth again. Get a little preload on it here. And you can see as I'm moving up, it's climbing. So I got to tap the compound again. Okay. There's a divot in it right there. preload here. Still climbing, so I'm just going to tap it a couple thou at a time here. I've got the compound pretty tight here, so you know when I tap it, it's just making slight changes. We're getting pretty close now. Yeah, a little more. Now, you know, this is a homemade taper here, so I'm probably not going to be able to get it precisely to the Morse taper, although this is pretty good. But, you know, the bottom line is when you're done, you're going to be filing on this thing anyway, so. You know, that's how you'll tune it in. Okay, I'm going to call that good. That's going to get us pretty damn close to what we need here, at least initially. So I'm going to torque these compound screws down big time here. Make sure. There's a divot in it right there. The other thing you want to do is check this for run out. I can't do it with the camera because the camera's magnetically connected to the chuck, so I'm going to have to move the camera to do it. But what you want to do is spin the thing, make sure that this is running true. Okay, so I've got the center in here. It's running out about a thou, which is about as good as you're going to get. And now you can see as I'm turning this compound here. It's pretty close. I mean, we're talking about 1/10 of a thou. That's going to get you to the point where you'll be able to finish this with a file, and that's why I made this a little bigger. The finished diameter of this on the big end is going to be 700 thou. It's 50 thou oversized right now. So what I'll do here is I'll keep cutting the taper, you know, with the compound until this gets to 700. And then this thing should be good. I probably have to trim off the end too. I left it a little long. So that's how you do it. That's how you dial in a taper. I'm going to start cutting it now. I got to set up my little motor on the compound here. So I'll get back to you when that's all set up. These are 5 thou cuts. I'm feeding in with the cross slide. And the apron is locked. Crank the feed rate up a little. I'm going to try a 10th cut, see how this thing does. Yeah, it's pretty reasonable. Still getting a good finish. So I won't record all this till we get down to the very end. I'll bring you back. Okay, I got some marking blue here, and I got my Morse taper sleeve. And I know we're too fat still because we left this fat. We did that for a reason. Because if this is off, I will have a chance to modify something before I run out of metal here. So let's see how this looks. Oh baby, that's pretty damn close right there. So I'm just going to continue. Now what will happen is, you know, I obviously can't get right up to the end here. So there will be a part where, you know, it will not, there'll be a step here. But that's fine, I really don't care. I don't want the sleeve running right up here anyways, because I won't be able to tighten it. I want to have a little, you know, so I can bang it. So I'll get the center back in here. And we'll just continue. It's not going to take much, so I'm going to start doing 5 thou cuts here, just to be on the safe side. It's really close. Okay, this is the final one. Very fine cut, very slow feed, and as you can see, it's a really nice finish coming out of here. That's the advantage of having a motorized compound is, you know, you get rid of all the hand stuff. It's a constant speed, and if there's any kind of slop in your lathe, it's not influencing it all. I mean, I think this will clean up with just some Scotch-Brite and maybe some very, very fine emery. So what I'm going to do here is when this thing finishes, it's probably at least a 5-minute cut. I'll break down this setup and I'll finish the ends, and then we'll turn it around and run it so we can machine the other end of it. But yeah, I'm quite pleased with the way this came out. Okay, there's the finished product. Finished off the ends, put a nice radius on the inside here, chamfered everything. So now this is coming out of here, and we're going to put it in that that sleeve adapter. Okay, I know some of you have seen this before, but this is the little gizmo that I designed that drives my compound. And what I've got here is I've mounted an aluminum gear. I got this from Actobotics, which is, it's an Actobotics gear I got from Robot Shop, and it's just, you know, I bored it out and it's screwed onto the back of the hand wheel here. And I've got another gear here, and what this does is I can, you know, set the speed. Goes both ways, and this sits right on here. Okay, so this sits on my compound like this. It's just a real tight fit. There's nothing really holding it down there except you know, I've made this thing so that it's a, you know, you got to really force it down to hold it on there. And the reason I did that is, you know, if something happens here and this hits the end of stop on the travel, then it'll just push this up and disengage the gears. So when I was cutting that taper, I can, you know, control the speed. So what's inside of here is there's a Pololu JRK motor controller, and it's a USB configurable motor controller and a driver. So I have 2 programs that I can put into this. One of them is this one, which is just the open loop speed controller, and the other one is that Trace-O-Matic thing that I had a video on, and I'll put the link up there if you guys are interested in seeing that. But that would be like a position control type situation. So that's how I cut the taper without having to, you know, turn this crank. And you know, when you don't have to mess with this compound with your hands, you know, it takes all the inconsistencies out of everything. You know, when you're turning it, you're not turning it at a constant rate, and you know, when you know, you can push on it and it'll kind of, you know, move, because you know the lathe isn't completely perfectly rigid. So I find that, you know, doing this way, I get much better taper turning with my compound. Alright, I got this thing mounted in here, and I'm just facing it off. And I gotta tell you, this is about the most accurate you can get on a lathe, because it's, you know, essentially right in the taper of the headstock. So yeah, we'll just clean this up and start making the thread. Okay, we're just facing this off, and the suck pump is working overtime here. Lucky I don't have to breathe that crap.